We are on the section 2.4, area of a rectangle, page 20 on your notes. We are going to talk about something called area and rectangle. So, you know this class is for stats, right? It's a pre-stats class, so get you ready for the stats class. And so far, on your chapter 1, we talk about what? The things we needed to use for the stats, okay? Decimals, fractions, and percents, right? And those numbers are interchangeable, so we convert them and we compare them, and for decimals we round them, right? So we need those numbers to do the stats. Also, on your chapter 2, we talk about signed numbers because we need to add, subtract, right? And also follow the order of our operations. Then we learn the algebra because we need to use the algebra skills, okay, to solve stats problem. All right. Then we also follow the order of operations. So order of operations for algebra, so it's like x squared plus 5. You have to follow the order of operations. So you do the square first, right? Then you plus 5. Then if x plus 5 take a square, what do? You will do the group first, right? Pandas. So you do the parentheses first. You do x plus 5. Then you take square. So we learned that in your chapter 2. Now we are going to learn another concept we need for the stats. It's called area of a rectangle, to use the geometry to visualize the probabilities. Okay, stats, you know, it's collecting all the data, then you make a prediction, right? Prediction. So use your algebra skills. So for the concepts, all right, for the possible things to happen, then we talk about probabilities. Then we visualize with the area of a rectangle, okay? So let's talk about, start from beginning. If I have 100 people and they are, you know, distributed, they stand up, you know, stand lined up with uniform fashion. So what does that mean? And so they just stand up uniformly, right? So I have 100 people. Then I say, if I have asked them to line up 5 lines, so what do you think each line would be? 100 people, right? 100 of them. So each line would be what? 20 people, right? If they stand up uniformly. So then if they stand on 5 lines, then I say, what's the probability for the people standing in the middle line here? What's the probability? What's the chance, right? So we are going to talk about probabilities. The chance for things to happen if they stand up uniformly. Okay, we call it uniform distribution, right? So if they say how many people, what's the chance they stand? If a person stand in the middle line, for the person stay in the middle, what's the chance? So what do you think? Total 100 people, who is in the middle line? How many of them? 20, right? So what's the chance? You stand here, not here. So you are the one of those 20 people out of whole 100. So the chance is what? 20 out of what? 100. So it would be what? 1/5, or you can say 0.2, or you can change it to percentage, interchangeable, right? 20% chance. If we pick you up from all these people, in the middle, the chance to pick up is what? 20% out of the whole population. Is that right? So if we say, what's the chance for you to stand in the first 2 lines? First 2 lines, how many people? Total, you are one of those 40 people out of how many? 100 people, right? So that would be 2/5. That would be what? 0.4. That would be what? 40% of chance you will stand up on the first 2 lines, right? That's how we see it. Okay, so if we have this situation and 100 people, so if we say we mark here 1, 2, 3, marker is here, right? Mark from 1 to 6. How many lines you have? So you do 6 minus 1, so you have 5 lines. That's how we see it. Okay, so the chance would be what? To happen would be, that's your probability, right? Things to happen, the chance to happen would be what? Total would be what? 100%, so would be 1. Okay, so whole thing we consider as 100%. Then we say, okay, what's your percent happen on the 4th line or 5th line or the last 4 lines? That's how we are going to do it with the area of a rectangle. So it's a rectangle shape in the situation of what? Uniform distribution. You stand up uniformly, right? Okay, then let's get into some concepts of the rectangle. Okay, so first let's talk about rectangle, how we will use this concept, okay, to do the probabilities and to do the stats. Okay, so first we are going to, because it's rectangular shape, right? Then we want to count the whole thing, whole area. So how do we look at the area? So bottom we call it what? The base. The side we call it what? The height. So if you have a table, how do we measure things? If length, you just walk how many steps, how many feet, so you measure it. But for the area, it's always measured by what? A square thing, right? So if it's 1 foot here, 1 foot here, what's the area? It will always be a square, right? So the area will be what? 1 square thing, 1 square foot, or 1 foot square. Okay, so that's how we measure your house, how big the house is. Then you measure it by the square. If you have a table, say here is 5 feet, here is 3 feet. How we will describe how big the area is? So 3 feet, you have 3 of them, 2, 3, 4, 5, right? So how many square you have? What do you think? 3 here, 5 here. What do you do? 3 times 5 will be what? How many square you have? 15 of them. So we say 15 square feet. So it would be what? Base times height. Okay, so the area would be, we want to measure how big is a rectangle, right? Then we do the area would be what? Base times height. That's how we do it. Okay, so look at your paper on the top to describe the rectangles. It says rectangles are of fundamental importance in the portion of statistics that involves the uniform distribution. You will learn this real meaning in stats class. But you can see, if I have a bunch of people, they stand uniformly, then end up they all have what? Same size, right? Okay, every rectangle has a base and height. Like here, what's your base? Base would be what? You will measure it would be 5, right? 6 minus 1. And so the formula for the area of a rectangle is base times height. When we work with the uniform distribution, the area represents the whole area, represent the probability of an event being within the bounds of the base. Within here, so this is the event, how people lined up, right? So whole event will be what? It happens is 100%. Whole area is 1. That's how the concept we are going to use. Okay? So let's practice the rectangles first. Then we are going to apply to the probabilities. Okay? So if we have area look like this, so you have from 2 to 8, then height is 3. Find the area of rectangle. So what's your base? The length, the difference. So base is what? 8 times 2, right? So that's your base. So it's a 6. Your height will be 3. So what's your area? Base times height. So that would be your area. If each side is a foot, then would be 18 square feet. So if each side is a meter, then that would be 18 square meters, right? Look, the second one, it turns out that the area of the rectangles that equal to 1, okay, it is given because we are going to use this, for the uniform distribution, the rectangle, we whole thing, the area, we will call it 1. It means what? 1 is 100%. Okay? Let's see how we are going to use that concept. So, it turns out that the area of the rectangles that equal to 1 will occur the most often for a uniform distribution. So everybody do it uniformly, same height, right? Suppose that we know that the area of a rectangle that depicts a uniform distribution is equal to 1, and that the base of the rectangle goes from 4 to 7, find the height of the rectangle. So if I have a situation like this, okay, the picture is not to the graph. Actually, it's almost like that. So base is 4, 5, 6, 7. If the whole thing, area is 1, right? Area is 1. That's what we are dealing with for the uniform distribution. So if I have this, what's the height? If we do that. So your area equals what? Base times height, right? So your base is what? The difference, 7 minus 4, is 3. So 3 times height is what? Whole area is 1. What do you think the height would be? Your height would, we are going to learn how to solve this algebra equation, but at the moment, you know, 1 equals 3 times height, your height would be what? 1/3, right? 1/3 times 3 would be 1. So that's how we find our height. Okay? Then look at the example 3. It says, suppose that we know that the area of a rectangle that depicts a uniform distribution is equal to 1, right? So the area is 1 and the base goes from 3 to 5. So we look at the picture. So here is 3 to 5. Okay? Then there is a smaller rectangle within the larger one with the same height, right? Uniform distribution, they all have the same height. But whose base goes from what? That's 4, goes from 3.77 here, 3.7 to what? 4, that's 4.4. Something like this, okay? The base. So if they have same height, if your base only go from 3.7 to 4.4, we are talking about this area. It says, find the area of the smaller rectangle. We want to find this area. The whole big area is what? The whole thing, big area is 1, right? Big area. Then we want to find the blue area. How big? The question is, how big is the shade area? So that's the question. Just like, okay, how big is the people who stand in the middle? That would be 20%, 0.2, right? Compare the whole thing, 1. So that's the same thing. So things happen in this area, shaded area, and how big it is? Whole thing is 1. Okay, so it means what's the chance things happen in this blue area? So that's why we want to find out how big the area is. Then that will be your probabilities later. Okay? So how we are going to do it? So you have 2 methods, okay? I usually do this method, but all your book and all your homework, it will show you use the method 2 using the height, right? Using the height to do that. Method 1, I'm just going to use the portion. Because they are uniformly distributed, so that means, you know, you just compare how big the portion the base is, then that will be the portion of the whole thing, right? So I want to compare the bottom, okay, how big this blue area, shaded area, occupy the base. That's the approach, right? So the total base is what? Difference, right? 5 minus 3, so it's 2. Okay? Then, what's the portion? The one I wanted to calculate. So the shaded area, shaded base, would be what? 4.4 minus 3.7, which is what? 0.7. right? So what's the portion, the shaded area compared to whole, right? So the portion will be what? 0.7 divided by 2. Turned out is 0.35 compared to whole, right? So it means what? The shaded area, that is the shaded area, is what? 0.35. Or you can say 35% compared to the whole thing. Okay? If we use the height, you know, you want to find the shaded area, all you have to do is just base times height, right? But we have to find the height first. Then what is the height, right? We know the whole area is 1, right? And whole area is what? Base times height equals 1. What's your base? Base is 5 minus 3, right? Base is 5 minus 3 is 2. So 2 times height is 1. That means what? Your height is half. Right? Okay. So if height is half, then the shaded area will be what? Shade area will be the shade base times height, right? The shaded area. What's your base of shaded area? Is this one, right? 0.7. 0.7 times your height is what? Half, which is 0.7 times 0.5, which is what? You multiply them is 0.35. Okay? Do we have the same answer? Yes. That's how we do it. Okay? So if you use the second method, use the height as all your homework. That's, you know, that's how they do it. But for the uniform distribution, you can just compare the portion, then you got it already, right? Portion of the whole would be, whole thing is 2, right? Then the area, shaded area base is 0.7, so it occupies 0.35, 35% of the whole thing. You can just do that directly to find the answer. But if the homework asks you to do the height, ask you about a height, then you have to do it this way. Okay? So look at the next one. Births are approximately uniformly distributed between the 52 weeks of the year. So the person will be born, you know, from what? Within that 52 years. They can be said to follow a uniform distribution from 1 to 53. So we want to make base become what? 1 to 53. Okay? So after the first week, right? Become second week, first week, third week, all the way to 52, the 52, 52nd week to the end. Okay, so total would be 52 weeks from week 1 to week 52 until end of almost the starting of week 53. That's how we see it for the base. Okay, the distribution of the births is depicted below with a rectangle whose area is 1. Remember, when we do the uniform distribution, we always use the area as 1. The shade rectangle represents the probability that a randomly selected person will be born between 19.47. So we want a 19.47 here, 19.47 to the week of 34.07. We are talking about this portion. Okay, so total we use this rectangle to do that area is 1. Okay, so we just say, okay, so what's your chance? Well, you were born between the week 19.47 and 34.07, between those weeks. All right, for the person to be born in that frame of time. Okay, so you compare the whole thing, it's 100%, right? What's the percentage it happens in here? So if we use method 1, I just do the comparison, use the portion, right? So my total base is what? Is the 53 minus 1, so it's a 52 weeks consider. We do that. Then the shade base is what? The difference of this, 34.07 minus 19.47, which will be what? 14.6, right? So the portion, what do we have? What's comparison? Part of the whole, right? So portion for the shaded area will be 14.6 divided by 52. Then you use your calculator, you get a 0.2807, something like that. Then it says what? Usually if it didn't tell you, we just round it to the 4th decimal, okay? So we don't want this, we increment this, will be 2.08. So that's the portion. Okay? Then if we use method 2, now use height. How do we do that? Okay, let's find out. With the method 2, right? So whole area is 1, okay? So the whole area is 1. It's base times height, right? It's 1. Then base is what? 52 times height is 1. So what's our height, right? It's 152, 150 seconds, right? So you cancel out, it become 1. So we have a height. Then the shade area would be what? The base times height for the shade area. Then shade area base is what? 34.07 minus this is 40.6 times what? The height. That's how we do, right? Then you use the calculator. If you do it, 1 divided by 52, right? You will do that first by order of operations. Then just follow the rule. So then that would be, we do it, you end up 0.280769, same thing. Then round it to the 4th place, we will have what? 0.2808. So it's about 28% of the blue area, and compared to whole 100% of the area. Okay, that's on your page 21 for the example 4. Got an idea how we use the uniform distribution to find the possible area, shaded area, compared to whole thing 1. Whole area is 100%, so the shaded area would be the possible chance it happens in this area, right? Between 0 and 1. Okay, so this is a portion here is 28%. Are we okay? So this would be your section 2.4.